Hello class, welcome to this video on the chapter 6 questions. So we're going to go over and review questions related to chapter 6, which was on polygons, interior angles, quadrilaterals, and so on. So let's go ahead and get started. So for question 1, first question, we are looking for the measure of one of the interior angles in the regular polygon. So it's a regular polygon, which means, remember that regular polygon means that the sides here are all congruent, but it also means that the angles themselves are congruent. So all these angles are congruent here, just like I indicated here. So we do know that this polygon has, if you count the number of sides, we have 1, 2, 3, 4. Wait, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it looks like a decagon of sorts. And so we know it has 10 sides, so n is equal to 10. Remember that to find the interior angles in a polygon in general, you use the formula n minus 2 times 180. Then if we want for one of the interior angles for each of them, then you divide by how many sides you have. And this only works for a regular polygon. And so we can plug in my 10 sides here into the formula. And we have 8 times 180 divided by 10. We know 8 times, or 180 divided by 10 is 18. So we just have to do 18 times 8 here, which in this case, if I do the math here, it should be 144 degrees. And just to verify that math. Okay, so it's 144. All right, so for the next angle, find the measure of one exterior angle in the regular polygon. So this time we're looking at the exterior angles. So we're looking at, for example, here, what that angle is, here, what that angle is, here, and so on. So you can continue this. And get all these angles. So if we know that if we add up all these angles, we're going to get 360 degrees for any polygon. And if we take 360 divided by the number of sides, that'll give us the measure of each of these exterior angles. And we know here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Again, we have what looks to be a decagon, just like it was here. And so we can take that divided by 10 and we get 36 degrees. All right, so if each interior angle of a regular polygon measures 140, how many sides does the polygon have? So again, if we use the formula for it's a regular polygon and we're looking for each of the interiors, so we're going to use the formula that we used earlier. And this is supposed to equal 140 degrees. So we can solve this. I'm going to multiply by n on both sides to cancel that out. Then I'm going to distribute this, and I get 180n minus 360 equals 140n. Then I can subtract 180n on both sides. I get negative 360 equals negative 40n. Then I can finish it off by dividing by negative 40 on both sides, leaving me with n equals, in this case, 9. So we have a 9-sided polygon. All right, for question number 4, find the value of each variable. So in this case, we have we have a quadrilateral. We have 4 sides, and we have some exterior angle here. So this exterior angle is 117. Now we know that because we have this exterior angle and this other angle, these two angles add up to 180, and so we can use that to find z. So we know that z plus 117 equals 180 because they're a linear pair. So we can subtract 117 and get z. So z is 63 degrees. So we got z, and since we know that this is 63, we know that for a quadrilateral, the interior angles add up to 360 because remember the formula n minus 2 times 180. If we plug in 4 into that formula, we get precisely 360 degrees. So these angles have to add up to 360. So we're going to add up all 4 angles, y plus the 93 plus the 87 plus the z that we just found, which was 63, that was z, which was equal to 360. And then if we can add these, we'll be able to get y. So 63 or 93 plus 87 is that's 180, and then 180 plus 63. So let's see here, 180 plus 63, that's 243. So y plus 243 equals 360, and then we can go ahead and subtract 243 on both sides. And we should get, let's see here, that's 7. So we get 117 degrees. And if you think about it, that does make sense because these 2 angles should add up to 180. Because for a quadrilateral, remember the consecutive angles usually add up to 180. If these add up to 180 rather, then these would have to add up to 180. So that makes sense that in this example. So we got 117 and 63. Okay, so find the missing angle measure. So we know that we have 1, 2, 3, 4, 5, 6. We have a hexagon, so 6 sides. So then if we apply the formula, we have 6 minus 2 times 180, which is 720 degrees. So these had to add for 720. So we can just go ahead and add up all these angles real quick. And they'll add up to 720 rather. Go ahead and add those up real quick. So we have 142 and 162. Okay, so that's going to be 304. 304 plus 552 is 356. Then we have 356 plus that. So that's 487. And then 487 plus 127. In that case, that's going to be 614 equals 720. And I'm just going to double check the math there just to make sure that we're okay. Okay, and then we'll go ahead and subtract them. So we get x equals 720 minus 614, which in this case is going to be 106. So the missing angle is 106 degrees. All right, number 6, what is the measure of angle Q? Again, this is very similar to what we've been doing. We add up the angles, and then since this is a hexagon, or 2, 4, this is a pentagon rather, because it's a 5-sided, we can use the formula for this for 5 instead of 6, and that'll give us 540 degrees. So these angles have to add up to 540. So we're going to add up all of them, starting from Q and working our way around. It doesn't really matter the order that you add them. I just add them in a specific order, just, you know, to make sure that I get all the angles and keep track of them. And they should equal 540. We'll go ahead and combine our like terms here. We got 2 and 3 is 5, 5 and 3 is 8, 8 plus 5 is 13, 13 plus 3 is 16, 15 minus 10 is 5. 5 minus 8 is -3, minus 2, -5, plus 1, -4. Then we can add 4 to both sides. We got 16x equals 544. Then we can divide by 16. So we get 544 over 16, which is 34. And so that's x, and then we can plug in to get Q, because remember this right here is Q, so we can plug that in here. So to get Q, we just simply have to do 2 times 34 plus 15. 68 plus 15 is 83, so it should be about 83 degrees, if I did that math correctly. All right, for question 7, we have a kite, ABCD, in which AN equals 2.8. So then what is AC? So you should know that for a kite, this angle is 90 degrees, but then this is bisected, so this is the same as that. So if that's 2.8, then this is 2.8. And so if I add them together, I get a total of 5.6. All right, question number 8, find the measures of the numbered angles in the kite. So again, we know that for a kite, the minor and major diagonals, that's these two diagonals here, the minor and major, they, in this case, they cross each other, they're perpendicular, they cross at a 90-degree angle. So we automatically know that angle 1 is 90 degrees. And then angle 2, we know that this is 28, and this is a bisector. Since this is the same on both sides, this is also going to be 28. So if that's 28 and this is 90, then you can figure out what angle 2 is, because angle 2, the angles in a triangle add up to 180. And we can use that to solve for angle 2. So we know that this is 118. We can subtract 118 on both sides, leaving us with 62 degrees. All right, question 9, find the measures of the numbered angles of the angles, or the numbered angles in the isosceles trapezoid. Isosceles meaning that these two are the same, and that means that the base angles here have to be congruent. That's congruent and that's congruent. Those upper and lower base angles are congruent. So if that means that angle 1 has to be the same as 36 degrees. And remember that the consecutive angles here add up to 180. They're supplementary. So that means that you can find angle 3 if you know the other angle. So those have to add up to 180. So the measure of angle 3 is 180 minus 36, which is going to be 134. Well, it should be 144. And so then this is 144, which means that this is 144. So we got all the angles here, and this is 36. All right, for question 10, we got another trapezoid. We have a mid-segment, EF. So this is a mid-segment, which means that we can tell it's a mid-segment because if you look at it, it's cutting this in half. This is the same on both sides, and it's also cutting this in half. It's the same thing on both sides. So it's truly in the middle. It's in the midpoint of each of the line segments here. So the midpoint, remember, to find the mid-segment, so in this case, EF, to find EF, you take the average of the bases. So you take the average of AD and BC. And if the average, so AD is, so let's do it, AD plus BC in this case divided by 2. And that's how you get the mid-segment there. So to get EF, but we know EF is 3x plus 4. So I'm going to plug in 3x plus 4. And then AD, I'm going to average these two, add them up, and divide by 2. Okay, so there's my equation. Let's make this simpler. So we're going to multiply by 2 on both sides, and that will get rid of this. Remember to distribute here. 2 times 3 is 6x, 2 times 4 is 8. We have 4 plus 2 is 6, so this is 6 plus 7x. So we can solve this. I'm going to subtract 6x here on both sides, leaving me with 8 equals 6 plus 1x. And so you can clearly see x is 2 here, 2 plus 6 is 8. So then we can plug that in to get EF, and so EF is 3 times 2 plus 4, which is 10. All right, and that gives us the length of the mid-segment. So now let's look at the next question. What is BD? So we're looking for, in this case, we're looking for this right here. Now we know that these are right angles because it is a kite, and it's labeled on the diagram too, in case we forgot. But if this is, let's see here. We know that this is 5 and this is 3. This right here is 3, and then the hypotenuse is 5. So this is a right angle here. This is a right triangle. So let's focus on this right triangle here. For that right triangle, we have 5, we have 3, and we're looking for A. And since it is a right triangle, we can use the Pythagorean Theorem. So a squared plus 3 squared equals c squared. Remember, a squared plus b squared equals c squared. And so we have a squared plus 9 equals 25. So a squared equals 16. which means if we take the square root, a equals 4. 4 times 4 is 16. So that gives us the missing side of 4 here. And if that's 4, then this is 4 down here because the minor diagonal gets bisected in a kite. So we got 1, 2, 3, 1, 2, 3. Those two are the same. So that means to get BD, we simply have to add the two 4s together or just multiply 4 by 2. We have 2 4s, which is 8. All right, the next question, we have another isosceles trapezoid, just like a few questions back. And we know that in an isosceles trapezoid, because it's the same distance on both sides, it's basically symmetric here. We know that this diagonal is going to be the same length as this diagonal. So we can use that to our advantage. We know that QR is 3x plus 1, and we know that our n is 6. So obviously the purple is, you can combine those two numbers and that gives you the length of the entire purple diagonal. And then for the red, they only give you MP. Well, they give you the whole thing. So they give you that this whole thing in red is 6x minus 5. Okay, so that means since we just said that the red diagonal is the same distance as the purple diagonal, then that means we can set the purple equal to the red. But remember that the purple is equal to the sum of those two components. And we could set it equal to the entire red. And that's my equation. We can go ahead and solve it now. Let's combine these like terms here. And let's subtract 3x on both sides. Then we can add 5 to both sides to get rid of it and get x by itself. So we can see here, divide by 3 on both sides. X has to be 4 since 3 times 4 is 12. And so that gives us x. And then we know we want to find Qn. But we already know that the purple, which is Qn, is equal to the red, which is MP. So if we know MP, we know Qn. And in fact, we do know MP. MP is 6x minus 5. So I'm going to take my x here, I'm going to plug it in there. So if I want to get, let's see here, Qn, I can just plug it into the red. So 6 times the x value that we got was 4 minus 5, which is in this case 24 minus 5 is 19. And that should be the same for the red and for the purple. All right, what are the values of AB and DE in the parallelogram ABCD? Now we know since it's a parallelogram, just like a rectangle is a parallelogram, we know that if this is 11, then this other side has to be 11. So these two have to be congruent, and these two segments have to be congruent in total. So obviously that means AB is 11. Now we know that if BC is 25, then AD also has to be 25. But we only know that this part is 19. So we'll call this X and solve to make it equal to 25. 19 plus what is going to be equal to 25? Well, if I subtract it, it's going to be 6. So that means this has to be 6 here. 6 plus 19 will give me the total of 25. And that's what we're looking for in the parallelogram. All right, for this next question, we have another parallelogram, and they want us to find the measure of angle n. Now, in order to do that, we need to figure out what x is. So since we know, looking at these two angles, we know that those two angles have to be congruent because we know opposite angles are congruent in a parallelogram. So opposite angles are congruent, which means we can set those equal to each other. So let's set those equal to each other and solve. So we got subtract 4x on both sides. We got 2x minus 2 equals 36. We'll add 2 to both sides. 2x equals 38. Then divide by 2. And x is 19. So we know what x is. And we can plug it in. Let's plug it in here and figure out what m is. So if I plug it in, I get 6 times 19 minus 2. 6 times 19, that should be... let's see, I want to say it's 144. Let's see, that's 54. Well, that's way off. 9 times 6 is 54, so that's 114. And then 114 take away 2 is 112. So this is 112. This red angle is 112 degrees. This is 112 degrees. So if I wanted to get this purple, which these two purples on opposite sides are congruent, remember that consecutive angles are supplementary. So these are supplementary. So if I wanted to get the purple, I simply add them to 180. So we get x, let's call it something else. Let's just call it y instead of x because we had x earlier. So y plus the red of 112 has to equal 180, which leaves us with y equals, subtract that on both sides, 112, you get 68 degrees. So that means these are both 68 degrees. All right, looking at the next one, for what value of x must ABCD be a parallelogram? So we have here, let's see here, we have a parallelogram and, okay, so we have what could be a parallelogram. We know that in a parallelogram, remember that in a parallelogram that these two diagonals are not equal to each other in a parallelogram. The purple one is actually slightly longer than the red one. But we do know that in a parallelogram that the diagonals get cut in half. So that means this is the same thing as this on both sides. So these two are equal to each other. So we get 2x equals 3x minus 9. Then we can subtract 3x on both sides, leaving us with negative 1x equals negative 9, which means x is 9. And so we got our value of x. Okay, so we have what looks to be a parallelogram, and it says if xz is 12x minus 8, so xz, so this part, and I'll color code that, is 12x minus 8, and we know that pz, so we know that pz here in purple is 5x minus 1, then what is xp? Okay, so we got xz, we have pz, and we just want xp. So we know that we can clearly see that the blue and the purple add up to the red. So we'll call this, and since the blue and the purple is the same thing as the red, we know that 2 purples is going to give me a red. Okay, so I'm going to just make this purple, and we'll say 2 purples is equal to a red. So that means 2 of these guys, 2 of the 5x minus 1s, right? So basically 5x minus 1 plus another 5x plus 1 minus 1 is equal to a red, 12x minus 8. So we can solve this. Let's combine these. That's 10x minus 2 equals 12x minus 8. We'll subtract 10x on both sides. Then we'll add 8 to both sides. And so we can see here x has to be 3 because 2 times 3 is 6. So once we get x, we can plug it in and get xp. Remember that xp is the same thing as pz. So if we know what pz is, we know what xp is. And pz is 5x minus 1. So let's go ahead and plug it into pz. We know that pz is 5 times x. So we got 5 times 3 minus 1, which is 14. Okay, so we got our value of xp. All right, so we got another parallelogram. It says find the side PQ in the given parallelogram. And we do know that since it is a parallelogram, that these opposite sides have to be congruent. So let's choose one of these pairs of opposite sides. So I will choose this pair. You can use either this pair or you can use this pair, but no other combinations. Okay, so I'm going to use the black pair here and solve. So we'll subtract 3x on both sides. Then we'll add 10. So x has to be equal to 3. And we get PQ is this guy, so we can plug it in here. 6 times 3 minus 10 equals 18 minus 10, which is 8. And that's how you would get it. Now you could solve for the purple and you would get the exact same thing. So for example, if I were to use the purple and I were to solve that, I should get the same exact answer, or something might be, or something that's wrong. Okay, so we get this, we'll add the 1 on both sides and leaving us with 2x equals 6. So we get x equals 3, which is the same thing, okay? And then, so no matter which equation, you should get the same value of x, and then you can plug in to get the answer. All right, so for what value of x must ABCD be a parallelogram? So again, for this to be a parallelogram, we know that these two have to be congruent, right? So we should be able to find that easily. So we'll set them equal to each other for parallelograms. We'll subtract 11x on both sides here. We'll add 5 to both sides here. And so 2x equals 12, which means x is 6. 2 times 6 is 12. All right, and that's how you get that. So it says, does the fact that yz equals wx lead to the proof that x, y, wz is a parallelogram? Okay, so basically they gave us the xy is equal to wz, but they're asking us, if they ask for that, if they say that this is equal to that, is that a parallelogram? And that would be yes, that is true, because as long as you know that you have two opposite sides that are parallel, we know it has to be a parallelogram. That's one of the theorems in the lessons. So yes, because if both pairs of sides are congruent, they must also be parallel, and therefore it's a parallelogram. Okay, so the next question here we have, for what value of x is this a parallelogram? So for this to be a parallelogram, remember that the opposite sides have to be congruent. So I could use either, there's a lot of combinations that you can do here, but I'm just going to give you two combinations here. I could say that this is equal to that, or this and this add up to 1, or those are equal, or I could say that these add up to 180 because they're consecutive, and so on, dot, dot, dot. I'm going to go ahead and just solve this one because that one looks easy. So we'll go ahead and solve that equation. Now, if you solve number 2, you should still be able to get the same answer. So I'm going to subtract 4x on both sides here. We get 13 equals x minus 8, which means x has to be, well, let's add 8 to both sides and find out. Add that, you get 21. Okay, so we got x is 21. Now try solving this, and you should get the same answer, just going to be a little bit more work. All right, so the next question, the diagonals of a quadrilateral intersect at point K. Select all the statements needed to prove that ABCD is a parallelogram. So we have something that's a quadrilateral, and we want to show that it's a parallelogram. So this is parallelogram ABCD, and they said that the diagonals intersect at a point which we'll call K. Okay, so remember that for a parallelogram that these have to be congruent and these have to be congruent on both sides, but they're not equal to each other. The red and the purple are not the same length. However, they do cut each other in half in the middle where they intersect. So it says CK is equal to DK. That is not true. The purple part is not equal to the red part. So this is not true. BK equals DK. Those two purple parts are equal. CK equals AK, those two red parts are equal, and BK equals AK, again the purple and the red are not equal, and that will make it a parallelogram. Find the value of the variable in the parallelogram. So we have what looks to be a rectangle, we have a right angle here, and we have two diagonals, and those two diagonals should be the same length, because in a rectangle the diagonals are the same length. So this red diagonal is the same length as this purple diagonal. It's important to know. So RZ is, this portion right here is RZ, which is 4x plus 7. And we have SW, which the whole thing they gave us is 9x minus 8. Now we know since the diagonals are equal to each other, that means, and we know that this should be the same on both sides. So if that's 4x plus 7, then this is 4x plus 7. And we know that the red has to equal to the purple. So that means 2 of these little reds is equal to 1 of the purple. So 4x plus 7 plus another 4x plus 7 is it should be equal to a purple. We're going to go ahead and solve this. We got 4x plus 4x is 8x. Those are 14. Now we'll subtract 8x on both sides here. And so we'll add 8 to both sides to get x. So x equals 22. All right, for the next question, find the values of the variables for the parallelogram. So we have what looks like a square, we have a right angle, and these two are congruent, which means that, you know, because this is a right angle and these are congruent and this is a 90-degree angle, there's a lot of things working out here. That means this has to be a square, which means that these two angles here have to be 45-degree angles. So that means these are getting cut in half. So that means that this 9x in red is equal to 45. And so is the 12z. So if you look at the 12z there, that's also equal to 45 since that's also being cut in half. So we can solve here and get x equals 5, divide by 12 here, and we'll get a weird number here, but we can still solve it and get some kind of value, 3.75. All right, for what value of z or x is the given parallelogram a rhombus? So now we're looking at rhombuses. Now in a rhombus, the diagonal here cuts the angle in half. So that means that the diagonals serve as angle bisectors. So this angle is the same as this angle. So we can set those two equal to each other. So 9x minus 6 equals 6x plus 21. We'll subtract 6x on both sides. Add 6, and so x has to be 9 since 9 times 3 is 27. All right, the diagonals of parallelogram ABCD intersect at P. Select all the statements that must be true. So we have, we don't really have a picture here, but we can draw one just to kind of visualize this. We have some kind of parallelogram, A, B, C, D. Remember that the naming goes like this, it goes around. Or this way, but just make sure that when you label your ABCD parallelogram that you label it in a way that you're traversing or traveling around the shape. And then it says the diagonals intersect at P, so we'll just put this as purple and then put this as red and purple, and they intersect at a point P. Remember that these two halves are equal and these two halves are equal for a parallelogram. So it says AP is congruent to CP. So is the purple congruent to the purple here? Yes, that's true. BC congruent to AD. So BC is congruent to AD. That is true. We can put these as the same since in a parallelogram, opposite sides are the same. Those two are the same as that. Okay, so that's true. ABC is equal to 90. So they're saying that this angle ABC is a 90-degree angle. So in this case, let's see here, ABCD, and okay, so they're saying ABC is a 90. It doesn't have to be a 90-degree angle in general. Like, so just because it's a generic parallelogram does not mean that has to be a 90-degree angle. So that's not true. Could be for a rectangle, but not for in general. CAD is congruent to ACB. So CAD, so they're asking about this angle here, is the same as ACB, this one. And that is true for a parallelogram because those are alternate interior angles. So remember that if you got a parallelogram here, so let's go ahead and show that better. That means that those two sides have to be parallel. And if you can see that, this is this red here is my transversal. Those are alternate interior angles, and alternate interior angles are congruent. So yes, that is true. BPC is congruent to APD. So BPC, so this angle right here, congruent to APD, and that is congruent just because those are vertical angles, so that is true. All right, the diagonals of quadrilateral ABCD intersect at P. If AB is parallel to CD and AB is congruent to CD, and triangle DPA is congruent to triangle DPC, what is the most specific quadrilateral that ABCD can be? Okay, so we have some kind of generic quadrilateral, and so ABCD, and so we got diagonals here, here, and here. They cross at P. Now it says AB is parallel to CD, and it says AB is congruent to CD, so that is congruent to that. And they mentioned that this triangle, which is DPA, so DPA, we'll just make sure that we look at this triangle, is congruent to DPC. And DPC is this one right here. So those two triangles are congruent. Okay, so then we know one more thing, since it is a it says here, what is the most specific quadrilateral? So since these two triangles are congruent, we obviously know that this side is the same for both of them. So that side is obviously congruent between both of them. So I'm going to mark that with 2 tick marks. That's by reflexive property. And then we also know that since these two triangles are congruent, that means that this side right here is congruent to this side right here. And we also know that these two sides are congruent as well. So those sides are congruent by side. Because those two triangles are congruent, that means all of those have to be congruent. Okay, and also that means that if we're looking at this angle right here, and I'll use another color here, this angle right here, between this 2 tick mark and the 4 tick mark, notice that that corresponds to this angle here, between the 2 tick mark one and the 4 tick mark one. So those two angles have to be congruent because those two triangles are congruent by CP/CTC. And similarly, these angles have to be the same right there. But this part is important because that means that both angles are identical. Those are congruent, which means that this diagonal is a bisector. So that means that minimum, this is a rhombus. So because a rhombus has this property. We also know that these angles are congruent here because of vertical angles. And these ones are congruent as well. Let's see here. Now, because these are congruent, that between the red and the purple, that means all of these angles have to be congruent in the middle. And which means that if they're all congruent in the middle, that means that they all add up to, 90 degrees because they're all congruent, and they have to add up to 360 in a full circle, which means that if they're all equal, it has to be all 90 degrees. So this is definitely a rhombus, 90 degrees in the diagonal and a bisector here. So we're going to call this a rhombus. Select all the statements that are true. So we're talking about squares here. So diagonals are congruent to sides. So is that true for a square? Well, we know for a square, if this is, for example, 1 on each side, and we're looking at this diagonal right here in purple is clearly not the same length. Clearly not the same length as the sides. So that is not true. The diagonals are not congruent to the sides. The diagonals are perpendicular. So if you do draw two diagonals, yes, they will cross at a 90-degree angle for a square. Consecutive angles are supplementary. That is true. If you look at these two angles, that's a 90-degree angle, 90-degree angle. Those are consecutive. They add up to 180. Diagonals bisect angles. Yes. So for this 90-degree angle here for the square, both of these are 45. So it bisects. Opposite sides are parallel. Yes, because it is a parallelogram after all. So opposite sides do have to be parallel. All right. So we have what looks like a trapezoid and an isosceles trapezoid with two diagonals. So we'll label this as red diagonal and this is purple diagonal. if wy is equal to 4.6, so wy is this whole thing. This whole thing is 4.6. What is mz? Okay, so they're asking for mz now. So this part right here. But we do know that mz plus this 3.2 part has to be equal to this red part. The purple diagonal is equal to the red diagonal. So we know that mz, whatever that is, plus the 3.2 has to be equal to the red part. And so we can do that and use it to solve for mz. So we'll subtract 3.2 on both sides, leaving us with mz equals 1.4. All right, so for the parallelogram, it says what is angle, the measure of angle BAC. Let's see here, angle BAC. So we're looking for this angle right here. Okay, so we're trying to find this angle. And so if I want to find the angle, we'll just call it x. Now we do know that this angle put together, 71 plus 45, is 116 degrees. And then remember that consecutive angles add up to 180. So this angle here, which is, I'll do it in purple, that total angle, and this black angle have to add to 180, okay? So the purple plus the black one have to add to 180. So what's the purple one? The purple one is x plus 27. And the black one is 116. So then if we combine those, that's x plus 1, in this case 143 is equal to 180. So we'll subtract 143 on both sides. And that'll be 37 degrees. All right, guys, that's going to do it for the video. I hope you found this useful. Hope you took a few things. And as usual, I'll see you in the next one.